Hey, good morning, everybody. This is Mr. Ainsworth, and I want to get into a little review here of some essential concepts from Algebra 1 and 2 that are going to be important this year in AP Pre-Calc. Okay, they may be simple, but they're really important. And the first one deals with the rate of change. So the goal in the first one here is given a polynomial function, discover the rate of change. Which rate of change of the rate of change is constant? So let's find out. So let's start off with a simple linear function, case 1 here. And remember, a linear function, that's y equals m times x plus b. That's first degree function. And notice our function here that I gave you is y equals 3x minus 2. And in the future, you may not be given the function, but I'm giving you the function here just so that you can see what's going on. Okay, I'm obviously at school. And then, so let's figure out, and recall how to get the rate of change of the function. So let's figure out the rate of change of x first. Okay, so the rate of change of x, called delta x here, is the change from -2 to 0, and that's plus 2. And then change from 0 to 2 is obviously plus 2, and then 2 to 4 is plus 2. We call this delta x. Okay, the change, so delta means change. Change, that's the symbol, okay? The delta symbol means change. All right, and so delta x would be the change in x, all right? And it's constant, so here it's plus 2 through the table, okay? So it's constant, but we're going to call that equal intervals too, by the way. So do equal intervals of x, or equal changes in x, result in equal changes in y in the for a linear function? So let's find out. So here, the change from -8 to -2, we're getting bigger here, so it's a plus 6. And then from -2 to 4 is plus 6. And then from 4 to 10, 6 plus 6. And then it's obvious, hopefully, from 10 to 16 is 6 here, and then 16 to 22, 6. So the rate of change in y, call it delta y, or change in y, is constant. Okay, now let's write that down. So rate of change here, right there. Fix that. Okay, so I'm going to use some just some abbreviations here, some acronyms. So rate of change, ROC. Okay, so notice that the first rate of change, which we call the first difference, is constant. So the rate of change is constant. This is also called the first difference, and I'll explain why in a minute. So the first difference is constant. And the question is, does this always happen for linear functions? Okay, so, and the answer is yes, of course it does, because you're going to try it on the second one here. Okay, I'm not going to do all these problems today. This is just a quick instructional video for those people that were not here. But the first difference is constant. So why do we call the rate of change, this number here, 6, the rate of change, which is we call delta y. Why do we call it the first difference? Well, let's talk about that. The way to get 6 by using these values is by taking one y value and subtracting the one before it. So if you take a look at, let's take a look at 4 and 10. To get 6, you go 10 minus 4, y2 minus y1. So y2 minus y1. You subtract 4 minus a -2 is 6. 10 minus 4 is 6. 60 minus 10 is 6. 22 minus, okay, the one before it is 6. That's why these are called the first differences. Okay, it's called the rate of change of y, but we also refer to it as the first difference. And if it's constant, you get to assume that it's linear. So, and this always happens for linear functions. So when you get a constant first difference, you know it's linear. All right, and you can try the second one here and on your own. Okay, but basically, the observation when you do this multiple times, this always happens. Okay, so I'm going to say, for all, in fact, let's put this in red, okay? So for all linear functions, all linear, which is the first degree functions, so for all linear functions, the first difference is constant over equal intervals. The first difference, the rate of change, okay, I'm going to put ROC here, all right, is constant over equal intervals. Now, by that, I mean delta x is constant, okay? Equal intervals. Okay, if you look in the first example here, delta x is 2, constant. All right, delta x equals 2. On the second one, delta x is constantly 4, okay? But on the first one, example that the delta x is 2. But you were looking at equal intervals. And that's important because if you didn't have equal intervals, guess what? You wouldn't have equal changes in y, or the rate of change of y, which is called the first difference. That wouldn't be constant. Then you'd have to kick in what's called the average rate of change. Okay, now, does that hold for quadratic functions, which are second degree parabolas? Well, let's find out. Okay, so let's take a look at some rates of change and then do some simple calculations. Basically, analyze it the way we did in the beginning here. So let's find delta x first. Okay, the rate of change here from -1 to 1 is +2. Is it constant? Let's find out. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. Oh, it is. So delta x is constant. Pretty obvious, I think, because the rate of change is 2. But does it result in equal rates of change of y? So let's find out. So given a parabola here, the second degree function, it's called a quadratic function. And you guys should know that because we discussed that in Algebra 1 and in Algebra 2. Okay, second degree functions are called quadratics or parabolas. Okay, what happens here? So let's analyze it. So what's the change from 1 to 1 is 0. Change from 1 to 9 is +8. From 9 to 25 is a +16. Oh my God, it's getting bigger. From 25 to 49 is +24. And then from 49 to 81, it's like +32 maybe. And then so obviously it is not constant. So right away, I can say the first difference is not constant. First difference here is not constant. That tells me that it's not linear, which we know because I told you we're starting off with a quadratic function. So it's not linear. So what do? Well, you take a look at the second difference. So the change in from 0 to 8 is +8. From 8 to 16 is +8. 16 to 24 is +8. And then 24 to 32 is +8. And voila, the second difference is constant. Does that always happen for quadratics? Well, guess what? The answer is yes, it does. And you're going to see that in the next one. So here, this is called the second difference. So the second difference is constant. And that implies that it's quadratic. So you're gonna analyze tables of values, and you're not going to know the function, and you're going to take the first difference and see if it's constant. And if it isn't, you're going to do it again. And if the second difference is constant, you get to assume it's a quadratic or second degree function. And if it's not constant, then you do the third difference and the fourth difference, and you just keep on going. Okay? All right, you do second example on your own, and you can check my Canvas here and my website to check the solutions if you like. Okay. Concept 2, average rate of change. Oh, actually, wait a minute. Before I do that, let me write down the observation. So for all quadratic functions, for all quadratics, for quads, which are second degree functions, the second rate of change, the second difference, okay, the second difference is always constant. Over equal intervals. Okay, so there we go. Now let's switch concepts. Concept 2, finding the average rate of change. Look at this right here, average rate of change. I'm going to abbreviate that AROC, okay, and let's define it. We start talking about this in Algebra 1. Okay, I'm going to start simple here. We're given two different linear functions here, and we're going to calculate the average rate of change. So let's define it first. You should already know this, but let's go over basics. The average rate of change, you got to take delta y and divide it by delta x. Okay, this refers to the slope of the function. Okay, so let's go for it. So the change from -4 to 0 is +4. Is that constant? Let's find out. So 0 to 4 is 4. 4 to 8 is +4. 8 to 12 is a rate of change of 4. 12 to 16 is +4. So delta x is equal to 4. Okay? So what is delta y? Well, let's figure it out. Okay? From -8 to -5 is a change of 3. -5 to -2 is a change of 3. -2 to 1 is a change of 3. 1 to 4 is +3, and so on. So delta y here is equal to 3. Okay, so I know delta y, I know delta x, and now we calculate the average. rate of change. So we take delta y, which is 3, divided by 4, and there's your average rate of change, which represents the slope of the function, which, if you look at it right here, it is correct. Okay, so we knew the average rate of change had to be 3/4 because people coming out of algebra 1 and 2 know that the average rate of change for a linear function is the slope of the line. Okay, so I was expecting 3/4. All right, so go ahead and do that on the second example and then check your answers online. Okay, concept 3, find the average rate of change given on an interval given the function. Okay, so here the interval is from -3 to 6. These are x values from, let's say, x1 to x2. Okay, so x1 to x2, there's your interval. So let's set up a table here just to get organized. All right, so from -3 to 6, there's our interval. And then we need some y values here for the function. So to get a y value, we substitute the x value in. So let's show our thinking right through here. So f of -3 is equal to 2/3 times -3 minus 1. Okay, 2 times -3 is -6, divided by -3 is -2, minus 1. Well, guess what? That's equal to -3. And then the other one, so f of 6, you got to substitute that in. So 2/3 times 6. 2 times 6 is 12, divided by 3 is 4. 4 minus 1 is 3. And then after you get your values, we do the same thing as we did up here. It's delta y over delta x. Okay, so here, this from -3 to 6 is a rate of change of 9, and from -3 to 3 is a change of 6, and there's your delta y. So I can see that the average rate of change, which is always delta y over delta x, is 6/9, and if you simplify that, you get 2/3. Okay. All right, and we were expecting that because guess what? That is the slope of the line given, okay? And that's equal to the average rate of change. They are the same, guys, same concept. Different words for the same concept. So you can tell that it makes sense. All right, you do the same similar thing here for the second one, and then check my solutions. On this one here, we're given a graph instead of a function. So again, the average rate of change is equal to well, in general, it's delta y over delta x. But really, guys, we're dealing with two linear functions here, and it's equal to the slope. And as you guys learn in Algebra 1, that's rise over run. So there's a few different ways we can do this. And we want to figure out the average rate of change on this interval from -1 to 1. So notice the x values. Here's -1 and here's 1. And we want to figure that out. So here we go. So you can go do some rise and run first. You can do it graphically. Okay. So I can see that delta y is equal to, well, it looks like 4. Up 4, and then right 2. So delta x is 2. So just looking at the graph, I know that delta y over delta x is equal to 4 divided by 2, or 2. That's one way to do it. Or to get the rise and run, you could use your definition of slope that you learned a long time ago. So y2 minus y1 divided by x2 minus x1, which is how you find your rise and run. So the other way to do it, to get the slope, you take your values. So you start off y2 and you subtract y1. So -5 minus a -1, all divided by -1 minus 1. And then you simplify it. I see a double negative up top. -5 plus 1 is -4. So I see -4 up top, divided by -2 down below, and guess what? That's 2. So you can do it graphically or algebraically, either one. All right, and then do the second one when you're ready. Okay, concept 4, solving algebraic and trigonometric equations. Okay, so the first basic thing that we need to go through here is solving a quadratic function, and there are 3 methods possible. So 3 methods that you could choose from. Okay, you could solve it by factoring method. You could use completing the square method. So 1 here, 2 here, 3. Third method is quadratic formula. Now, if it's factorable, I always choose factoring because it's easier. So I'm going to try to factor this. I know that, or I'm trying to think right now, two numbers that multiplied -8 and add to -2. And I know those numbers. We played this little number game in class all the time back when you were young. So what two numbers multiplied -8 and added -2? And I don't know about you guys, but how about -4 and 2? Okay. So I'm just going to go right to factoring. So we can factor in two binomials. I know x times x is x squared. That gave me the x squared term. I'm going to use my factors of -4 and 2. And then you can multiply those two binomials and check it. That's equal to the given polynomial up there. Okay, so x times x is x squared. Look at the outer product here. X times 2 is 2x, and then -4 times x is -4x. When you add -4x to 2x, you get -2x, which is your middle term. And then FOIL, you got to go -4 times 2 is -8. So it's correct. And then we have a zero product. Okay, if we have something A times B equals 0, that tells me that either A has to be 0 or B has to be 0. That's called the zero product rule. Zero product rule. And that tells me that if I have this equation here, x minus 4 times x minus 2 equals 0, either x minus 4 has to be 0 or x plus 2 has to be equal to 0. Here it has to be 4, because 4 minus 4 is obviously 0. And here it's got to be -2 because -2 plus 2 is equal to 0. All right, so factoring, if possible, is probably the easiest if you know how to factor. And if you don't, then you use a different formula. So you do the second example. Let's go to concept 4. This is a different type of factoring. So notice that this quadratic here is missing the constant term. So what we want to do is factor out a common factor. So let's go ahead and do that. So when you factor this, I know they both contain 2 as a factor and they both contain x. So here we go, I'm going to factor out a 2x here. So 2x times x give me my first term, 2x squared, and then 8x divided by 2x is 4. Checking, 2x times -4 equals -8x. And then now we have a zero product, so either 2x equals 0 or x minus 4 has to be equal to 0. Here, hopefully it's obvious, it has to be 0. 2 times 0 is usually 0. And since 4 minus 4 is 0, x has to be 4. Okay? So you end up with two solutions here. All right, so you factor out a common factor, which is in this case is equal to 2x. And then you set each equal to 0 and you solve them. And then the next one here, believe it or not, these trig equations are just like the previous ones. They are the same form, so what we want to do is the same thing. So what we want to do is factor out a cosine theta, and we're trying to solve for theta. Okay, so I'm going to factor it out here. So cosine of theta, which is an angle, remember theta is an angle, times what? Well, cosine theta times cosine theta gives you cosine theta squared. Cosine theta times a -1 gives you cosine theta. So now you set each equal to 0. So when is cosine theta equal to 0? And when is cosine theta -1 equal to 0? Well, the first one I'll talk about here in a minute. The second one, you got to add 1 to just isolate it. So the second equation simplifies to cosine theta equals 1. So when is it equal to 0 and when is it equal to 1? Well, that relies upon the unit circle. Okay, so I'm going to draw a unit circle here. Now, unit circle is radius 1. So r is equal to 1. So this is 1, 0 up here at 0 degrees. And this is 90 degrees, and this is 180, and this is 270. Hopefully this makes sense to you guys. And then right back to 360 degrees here. You could do it in radians as well. All right, and then up top here, guess what? That's 0, comma 1. And then here, it's negative 1, comma 0. And then here, 0, comma negative 1. And on the unit circle, what you have to know and understand is that the x-coordinate is equal to the cosine of the angle, and the y-coordinate equals to the sine of the angle. Okay, so this right here, this knowledge of how to use the circle and how to read it is important. So just looking at the diagram here, I know the cosine of 0 is 1. Okay, I just found a solution. The cosine of 90 degrees on this circle is equal to 0. So here on this first equation here, theta could be 90 degrees at the top of the unit circle, because again, it's the x-coordinate, so focus your eyes at the top of the unit circle here. And then it's also 0 at 270 degrees, or 3/2 pi, so 270. And then you go back up, keep adding 180, all right? So, and this keeps on going. There's an infinite number of solutions here. And then on the second one, where is equal to 1? So when is cosine of what angle is at 1? And it's at 0 degrees, all right? Because it's always x, comma, y. Or you can even write it as cosine theta, comma, sine theta, okay, on the unit circle. Cosine theta is the first number, and the sine theta is equal to the second number. So here, theta could be 0 degrees, and then 360. And you just keep adding 360, so 720, dot, dot, dot. Okay? So yeah, it takes knowledge of the unit circle. All right, and then you can give the other one a shot. Same idea. You factor out a common factor and go for it. So believe it or not, that what you learned in Algebra 1, which is at the very top of the screen, applies to what you do in Algebra 2 when you get to trig. All right, and there's a short little video tutorial of the concepts that we covered in the first few days of class. All right, this is Mr. Ainsworth. I'll see you in class. You guys take care. Bye-bye.